warahmatullahi wabarakatuh. My name is Siti Zulaikha binti Muhammad Zuki. I'm a student under supervision of Associate Professor Dr. Razia Muhammad and also by TS Dr. Nur Azizah binti Saadun. And today I'll be presenting my progress report of my thesis titled Self-Adaptive Ontology-based Framework for Dynamic Service Discovery. For the overview, self-adaptive is the ability of a software system to adjust their behavior in response to the perception of the environment and the system itself. And then the ontology is an instance of mechanisms that can be used to represent a chosen field of knowledge explicitly. And finally, the web service discovery is the process of automatically detecting devices and services on the network. So for the problem background, so as we know, the popularity of web services has been steadily increasing together with the development of web service technologies, and also after the introduction of the semantic web technology. And as service-based technologies has become more preferable, there are now huge amount of web services that are available and can be found on the internet. And so this brings new challenges to web service discovery processes, where also in addition to that, there are also multiple services that have been created with probably similar functionalities and similar description that exist on the internet all at the same time. And due to this, the discovery agent would need to look further than just the what it has been doing in the traditional web service discovery, where it should be looking more than just at the service functionalities. It should also have to consider the non-functionality qualities and also the user contact as well as the service contact itself. So this brings us to our problem statement, that is how to model an ontology-based framework for dynamic service discovery that is self-adaptive, and also it can track and update changes based on the users and the web service contacts, and also based on the user's environment. The research aim is to model a self-adaptive ontology-based framework as a support to the dynamic survey discovery process, where we have derived three objectives to achieve this aim. The first one is to design a personalized user filter for a self-adaptive web survey discovery. And second, to design a matchmaking algorithm for dynamic web survey discovery. And the third one is to evaluate the reliability and the adaptability of the self-adaptive ontology-based framework after each cycle of changes that have happened in the system during the runtime. The expected significance from this research is to reduce web service search space by filtering the web services into sets of candidates for the discovery agent, so it does not have to look in the entirely huge database of web services. And then second, is allowing the web service discovery process to perform better by implementing web service filter as a pre-processing task before the web discovery process takes place. And then a matchmaking algorithm that can that also consider the relation between the user requirement, the user contact, service description, and also the web service contact when it performs similarity matching during the web service discovery. And then finally, a web service filter that is adaptable to changes, where it can be updated when new information is received or information that it already has made changes. In literature review, we will be looking for at two topic, that is web service filter and also self-adaptive system. So as for web service filter, we have identified that there are several common issues and motivations that have been addressed by several papers where they have produced some contributions and uh, also stated that some limitation and ways to improve them. So the first issues is that the restriction of UDDI and WSDL on syntactic matching hurts service discovery accuracy, where many researchers have stated that using semantic matching might increase the rate of the accuracy. So the first work is by Shu and Rahimi in 2016. They use user preference, service features, and environment to be considered during the service discovery itself, uh, and also used based on the similarity between the user requirement and also the service functionalities. However, in the paper, they have stated that the accuracy of their service discovery framework can be further improved by using more of QoS parameters. However, by also using more QoS parameters, it might also increase the workload and might cause lagging in the process. And then Jia et al. In 2017 has introduced a framework that is an algorithm that is a four-layered web service filter, where this layer works continuously, subsequently from top to bottom, where as we go down each layer, this threshold and the parameters evaluation will be stricter. For example, if we input about 1,000 data set in on the first topmost layer. So as we go down every layer, more and more web services that does not stand up to the threshold will be removed from the consideration, and finally, only a smaller set of web services that will be produced and passed to the web service discovery agent to choose from. And then as for Sharma et al. In 2015, they introduced a framework that used semantic relatedness score and also web hit score as mean of evaluation, where so in this paper, they not only look at the relatedness score, they also evaluate their web service to choose from based on the popularity of web service itself. And then also in this framework, they allow user to set the threshold value themselves, where as it works almost similar with Java from before, that any web service that has lower threshold than what was said before will be removed from the consideration by the web service discovery agent. So as for the limitation for both of these two papers, the result of the accuracy result will be different depending on the threshold that was set, and also that these two framework does not store any information or result from the previous iteration. So that means that for each time a user deploy a request, the framework and the algorithm will have to redo all the process from the top to bottom again. And for the second issues, motivation is the huge amount of web services about the big search space, and also about the centralized structure of service registry that could cause low accuracy in service discovery. And also, as I mentioned before, about the multiple services that have similar functionalities and description that exist on the internet at the same time. So Kala et al. In 2016 and Bellarmine et al. In 2017, they use usage history to group together these users for more efficient and less costly web service lookup. So what they did do is some sort of collaborative filtering, where they group users together and evaluate the user's context and requirement as a whole. So in order to group these users together, they assign personalized user profile to each of these users so that they know how to group these users together. And the limitation for these two papers are that since the framework requires to examine users profile and also the users log, so the user might be prone to cyber attack as their profile is in public. And then in 2020, Botejan et al. They use geographical and functional relevance of users and services to create a metric factorization model. However, the rate of in this paper, the rate of the accuracy, it depends on the latency dimension. And then finally in 2018, Xiong et al. They use deep learning to characterize the complex relation between services to create interaction metrics. So these services are grouped in contrast of the other two previous works where they group users instead. So in this work, they group service itself based on the level of the similarities. And the limitation for this paper is that the framework is not adaptable to receive new set of service as an input, which means that the framework has a fixed input, so it is not adaptable. So and for each set the training need to be done to create the metric. So that means that for every set, the process have to be done again from bottom to top. In this diagram, we show the conclusions of the works that I have mentioned before. So as we can see, there are this paper can be generally uh, divided into three, where they use the discovery stage. So some paper implement the web service filter before the discovery process took place, and some paper also use after the discovery process took place. And of course, the most popular one is that they apply this filter in to run at the same time of the discovery process itself. And then these papers also use some similar filter parameters to build their web service filter, that is to consider the user log, user group, service attribute, and then also the service threshold. And they monitor the profile context and also the service context. Next is we will be addressing the issues, motivation, and the contribution of papers in self-adaptive systems. So the first issues and motivation in self-adaptive system frameworks is that there are diverse and elaborative sources that are required to be processed, challenges the system capability in understanding and interpreting the context. So in 2015, Rani et al. Had used the ontology to store web content, which then they can predict other related web content for the user based on the user's behavior. And then in 2017, Temorikia and Fugini had used ontology to assist the decision support system after the interpretation of context based on the risk assessment. And the second issues in self-adaptive system is that the capturing of a higher level of generic concepts and then to model the specific information of context into hierarchical manner as the domain expands. So in 2018, Anguilla et al. They created a general meta-ontology for context modeling to derive domain and also to derive user activities to build a relationship between the concept. So this knowledge ontology is easily expandable when new information is added. So it is very good to be used as part of a self-adaptive system. And then the third issues is in data warehouse, the huge number of queries would take more response time, which can cause lagging depending on the device performance. So in 2020, Raza et al. They developed an autonomic performance prediction framework to monitor and forecast query performance and to manage the query evolving behavior by retaining query changes. And then finally, the last issue is that the dynamic adaptation in context-aware service-based application is much needed for continuous learning as sources can expand and more knowledge gets added. In 2017, Buddha et al. They use ontology to model context information and also a meta model to encapsulate different context-aware logics. So the ontology can easily be extended to cover the new knowledge. As for the research, this is the research framework that I have derived to achieve our aim. So the first phase is to do the literature review. And the second phase is to design the research, where first we design the research plan, and then we will design the personalized user filter with also that also include an adaptation logic model that will handle the self-adaptive part of this filter, and then also to design the matchmaking algorithm. And then in the third phase, we will implement this design where we will implement the user filter with the adaptation logic model, where we will connect the uh, adaptation logic model to the database and then implement this model to monitor and also update the personalized user filter when it is needed. And then we also will implement the matchmaking algorithm into the framework. And finally, the final phase is to evaluate the performance. So this is the diagram of the identified problems to the proposed solutions. So as I mentioned before, the main problem here is that there are the copious amount of web services that are available on the internet now, and that these web services might have multiple services that have similar functionalities and also similar description. And then there is a need to consider the user's contact, user's device specification alongside the web service contact and web service properties. And then the sub-problem 3 is to also check the service filter module that it needs to be updated based on any changes that happens during the runtime. Also, any changes that happen based on the user's context. So based on the sub-problem 1, we can solve it by creating a matchmaking algorithm that can also consider non-functional requirement of web service, and also to develop an adaptive model that can monitor changes on both service and user side, and also to perform the updated task based on these changes. So these solutions can also address the sub-problem 3 alongside by creating a web service filter that can include or remove a web service from being a candidate to the web service discovery agent. As for the sub-problem 2, we can address it by creating a user profile that can store the user preference, the user's usage log, and also the user's device specifications. So this is the overall proposed framework for um, the proposed title. So as you can see here, is over here. So instead of directly connecting the survey discovery process to the web survey repository, so we will be injecting the personalized user filter in the middle, where this personalized user filter will be getting information from the user profile that we created based on the user's preferences and context. So this personalized user filter will also be connected to an adaptation logic model, where this model will monitor any changes that happens in the user preferences or the user context, and then it will update the parameters in the user filter according. This is the zoom in into the personalized user filter. So as you can see here, whenever user input a request, so the personalized user filter will extract information from the user, and then based on this information, they will calculate the similarity between the user context and also web service context, and also based on the set that has been produced by the first computing here, it will also compute to find web services that are also similar to the one that have been determined from the first step. And then after that, it will output a set of a smaller set of web service candidate. And then from here, the web service discovery agent will only consider the services to choose from based on this set that has been produced instead of directly looking into the repository. And then the web service will be returned to the user. As for this, this is the adaptation logic model, where it has four components that is monitor, analyze, plan, and execute. So this model will get input from the user profile, where inside the user profile, it will carry the user module that contains the user profile, and also usage log, where it consists of the web services that the user have used before, and then summarize it into as a preference, and then deliver it to the adaptation logic model to evaluate. And this model will also monitor the context module of the user, where it will monitor parameters such as the time, location, environment, device status, network bandwidth, and so on of the user. And then if there is any changes that happen in any of these two contexts, so this model will run and analyze, and then it will plan any changes that should be implemented based on the changes that happen, and then it will execute the changes uh, into the personalized user filter. And then this work as a loop. So this monitor component will always run. So it will continue to monitor the user profile, directly the user preference, and also the context module. That's all from now. That's all from me. Thank you.
Thank you, Ms. Zulaikha, for the presentation. As usual, if anyone has any questions regarding the presented research, you can ask them now. I have a question actually. So I see that there's a personalized user filter, right?
Yes.
So is it like some kind of recommendation system?
Yeah, it can also be looked like that, because this personalized user filter, it will produce some set of a number of web services based on the user requirement, user content, and also user request. So it will produce a list of web services. So instead of the discovery agent look at the repository that have many web services, so they will only look at this set of candidates that the filter have been produced. So it will also save time and will produce a more accurate, since these web services that have been chosen, they are chosen based on the context from the user itself.
So it's like it's recommending a web service to the user.
Yes.
So is it like collaborative filtering or content-based filtering? Collaborative.
Yeah, collaborative.
Okay, that's all from me. Thank you.
Okay, Assalamualaikum Zulaikha
Waalaikumsalam.
and others. And good day to others. For your research objective, the third one you say to evaluate the reliability and adaptability. But when in your research you say as research framework, maybe it's actually research procedure lah. I think right, the step that you want to conduct for your
Yes.
research. So research procedure. So you say the fourth one is performance evaluation, but yeah, actually you don't evaluate performance, right? So I suggest you correct that lah for your uh, have you have you done your proposal defense?
Yes, I did it.
So there's no comment on your this one. This is procedure. It's correct
Hmm.
performance evaluation.
Yeah, I don't think I received any comments on that.
So performance is different in software engineering. Performance itself has certain is the metric is different as compared to what you say here. The two adjective, uh, reliability and adaptability. So make sure you define correctly and then evaluate correctly lah. Is it performance? If reliability, is it performance? That's my suggestion lah. What I can see for your research significance. In your proposal defense, did you cite any papers, any existing works that highlight the research significance? Because this one I don't see any citation.
I
Do you include any citation
cite
or you just write as like your opinion to the research significance in your extended proposal?
in the first chapter.
Research significance, where do you put?
In the
You
first
write?
chapter, yeah. I did cite. I cite based on the papers that I also included in my literature review.
Okay, how many you cite? For example, first point, second point, did you cite any existing word to support the significant point here? If you don't,
I
just improve lah in your writing. Because if you can cite also in your slide, that's good lah to show that you base on certain work to justify the research significance. That's my suggestion. Okay, Zulaikha.
okay.
You talk about SMS is the system, right? SMS is system, but the one that
Sorry.
you actually you're looking at the framework, isn't it? Can you explain a bit the framework versus the SAS? So do you mean when you doing the comparison just now
SAS
for
is
SAS, you looking at the framework also or how?
for the SAS, I look at framework and also architecture that use ontology as a mean of to monitor their self adaptivity lah. So
Okay,
that's how I choose the papers to look at. Yeah.
okay. So you can go back to your slide for that point, the comparison. SAS. Basically, in this presentation, how many do you have?
For this inside here, I only included 5.
Five. Okay.
I think for the adaptive system that also use ontology as a means of to cater the self adaptivity. I think
Oh,
I found about 20 or something. So I only included the most recent one that also the one that I look at and based on to when I try to derive the adaptation logic model.
okay. So back to your objective just now. For the third one is on the adaptability, right? Reliability and adaptability. Can you go to your proposed framework? So which actually contribute to that factors, reliability and adaptability? Your actually are you writing your final thesis now?
Not yet, not final yet.
But it's good lah. You have the proposed framework already. If you go back to the overall proposed framework, your proposed framework. Okay.
This one.
So adaptation, adaptability. So it's not performance, right? Do you agree? I'm not sure. You have to check
Yeah, I
again.
uh,
It's not performance evaluation lah. I think the wording only that you use in your research procedure. And another one is reliability. So in web services, reliability is also measured, right? I understand. Reliability. Okay. I think that's all from me. All the best to Zulaikha.
thank you, Doctor.
Okay, Assalamualaikum Zulaikha.
Salam, Doctor.
Can you refer back to your first your objective? Okay, here the first objective you mentioned to design a personalized user filter for self-adaptive web service discovery for the first one. And then can you look your slide to your research framework? Here you mentioned about the design of adaptation logic model in your second part, research design, where you want to design the adaptation logic model. Are you really want to design that adaptation logic model? Instead, in your objective, you just mentioned the filtering parts, but you are not design the adaptation logic model. So that is a conflict here. Can you explain?
Actually, what I mean by design in here is more like where to implement or include or connect this adaptation logic model to the filter, and how can I connect the monitoring the monitor part and also the implementing part to the filter and also to the user profile.
So actually, are you designing or you just embed the current or existing model to your
More like
personalized?
that.
You are just using, right?
Yes.
So there is no design the improve or any new adaptation logic model, right?
Yes. So far, no.
So I think I think you should improve on that second research design lah, because you are not design, right, the adaptation logic model. You just
Yes.
use or embed the adaptation logic model to your personalized user filter, right?
Correct. Yes.
Okay, so it's back to then when you look at your research framework number 4 here, performance evaluation, seems I agree with the Dr. Shahida just now. So the here you mentioned the adaptive model evaluation. So here what actually you want to evaluate the model here?
So after we so here over here, I actually want to evaluate this one. This matching evaluation here. So what we do here is we want to check after this personalized user filter produce a set of web services. So we want to check whether these web services that has chosen is produced more accurately rather than whether this personalized user filter managed to improve the accuracy of the survey discovery process by producing this set of web services.
So it's been not explicit model, right? It's the whole of the personalized user filter, right? So back to your just now, your research framework just now. Okay, so the number 4 here, it's actually the matching part, right? The service discovery is the matching part evaluations. And then the adaptive model evaluation is actually where you have the output of the personalized user filter evaluation, right? Is it correct?
Yes.
So I don't think the model here is the correct one, right? So improve on that. Okay, I think my comment that's all. All right. Good luck
Thank you,
for the
Doctor.
next progress, Zulaikha. Okay.
Thank you, Doctor.
Assalamualaikum, Ms. Zulaikha. So I just want to ask, so about your research, right? How did ontologies help you in this research overall? Like, it's just a general question.
Ontology, it's supposed to be as part of the knowledge mechanism inside the adaptation logic model, which it will be connected to the ontology that used for the matchmaking.
So it's like some sort of storage for your knowledge, is it?
Yeah, sorry for knowledge, yes.
Okay.
Thank you everyone for the comment and questions. And thank you again, Ms. Zulaikha, for the presentation.
Thank you, doctors. Thank you, Lukman.
So now I would like to invite Mr. Syafiq to begin his presentation.
Assalamualaikum and a very pleasant day I bid to all. Okay, first of all, I would like to introduce myself. My name is Syafiq Manan, and my supervisor is Professor Dr. Dayang, and my co-supervisor is Dr. Johanna. And today I would like to present my progress report, which for my research, which titled Enhanced History-Based Discretization in Combat Testing. So this is the outline. So I think you can skip this outline. Okay. Before we go deep into the discussion for my research, I will want to highlight what is combat testing and what is discretization. So as general, combat testing is in the context of test generation is used to highlight the challenge during the software modification, which consists of many parameter input and interaction. Okay. Unlike test case presentation, combat testing is more focused on test case generation, and for test case presentation is more focusing on the ordering of the test case. Later on, I will explain more detail on test case presentation. For test case, for combat testing, it focuses on the test case generation, which utilize the use of parameter value into consideration. For example, like here we can see the diagram here. We have consists few parameter into consideration, and then if we want to, for example, here they utilize the use of two-way. Actually, the two-way here we can replace it with three-way, four-way, and fifth-way until 6. And the higher the value of this string, I used to call it string, the more the test case will be generated from this technique. For example, like for this, we utilize the different parameter value. We combine P1 and P2, P1 and P3, and etc. So it will utilize us to generating the test case later on. And the reason why we use combat testing instead of other technique, for example, like we have input of 15, and each of input consists of 3 values, and in terms of mathematical calculation, we should test more than 14,000 to test execution. And then besides that, it also in software testing, majority of the fault are also caused by, not only caused by single parameter input, but also it's sometimes the combination of different parameter input could influence the fault in terms of fault on the software testing. Then we go to test case presentation. Okay, in test case presentation, we want to reorder the schedule, the test case in the execution order based on the objective and criteria. Usually the objective and criteria, I will use the term of approach. For example, like we have different type of approach in terms of test case presentation. And one of it is requirement based, history based. For example, like what I'm going to do today is more focused on history based, and there are code coverage and many more actually. And then it's try to seek the optimal combination of order in test case execution. And the goal of this technique is want to maximize the early fault detection as early as possible. And the reason why is, according to Miranda, is provide a quick confidence to tester to detect fault during the software testing. And then we go to the problem background. Okay, from here I want to highlight a few problem related to test case presentation itself. The drawback of test case presentation, they assume the test execution execute the entire test cases. However, it will consume a huge amount of time for us to execute if we execute entire test case. For example, like previously I mentioned that it's more than million of test cases to be executed, and it will not very practical. And most of study in TCP-based are focusing on single factor only during the test case execution. This is become one of my later on contribution for my study, which I want to utilize the use of multiple factor in a history-based execution for TCP. And then in TCP, the use of TCP in Siti itself, lack of study incorporate history-based approach in research and process assigning of prioritization still need for the study, since that most of the current study is focusing on code coverage and interaction coverage of the approach itself. And then we go to the problem statement. For the problem statement, the main problem statement for my research is how to get a high fault detection rate by adapting the combinatorial testing and TCP technique using a history-based approach. So each of later on it has a 4 sub question, which first we want to know how to apply the combined testing in TCP technique, since that combined testing itself is focusing on test case generation, and while the test case presentation itself is focusing on reorder the test case into certain order of priority. And then we want to and then the second research question sub-question is how to improve the history-based approach itself. And since that I have previously mentioned that most of the history-based approach TCP highlight the use of single factor into consideration. So for this one, I will try to have a use of multiple approach, multiple factor. And then for the third one is how to integrate the TCP history-based approach in combined testing. And lastly, we want to measure the fault detection rate in the software testing, which to evaluate the effectiveness of our proposed method approach. Then we go to the research aim, which is the aim of this is to improve the history-based test case prioritization using combined testing, since this technique has triggered most fault on the software, which could result to improve effectiveness of this technique. And then this is the objective, which is for the first one is we want to enhance the algorithm effectively prioritize the test case based on history-based approach, where we utilize the use of multiple factor. And then for Siti, the use of Siti in TCP itself, we want to propose the use of history-based approach in prioritizing test case combined testing to evaluate the effectiveness of proposed solution compared to the existing approach that available currently. Then we go to the scope. This is quite straightforward, which okay, for the scope, my study is more focused on, for the case study, I have a case study, and for the experiment, I have a case study and benchmark data set, which is for the benchmark data set, I use SER and defect4j benchmark program, which should consist of history-based information that requirement factor that I have been considered. And then for, okay, this study also consists of these two techniques. And then we do some comparison in terms of solution for my proposed and existing proposed solution. Then we go to the literature review. So before we go to the this is the overview of the available regression testing technique. Actually, before we go jump to this test case presentation, actually we have 3 different of technique in regression. For example, like this one is for minimization, where from the word itself we want to minimize as much as possible the number of test cases. And for the test selection is we want to select, consider the test case should be re-execute, select which test case that possibly from prompt fault to be executed. And then for the prioritization, which is more focused on the objective and the criteria that we have cited. Okay, in terms of advantage itself, most of for both of these, they both try to reduce the amount of test case selected, and it will for sure reduce the time and the cost to execute the testing. Same goes with this test case selection. But however, for the test case prioritization, it focuses on the test case that potentiate the prompt default, which increase the ability to find fault in the test cases and try. However, there is some limitation for test case prioritization compared to the other. It will assume to execute entire test script, which consumes so much time and cost. Then, okay, this is the summary actually. So, from the reading of the lecture review itself, each application testing consists of pros and cons. Okay, both of test case minimization and selection try to reduce the amount of test cases. Unlike test case prioritization, they assume to execute the entire test cases. However, it will reorder the test cases into its priority. Okay, and then we only a test case prioritization technique assume, okay, and then test case prioritization technique focus on potential test cases to be executed as early as possible during the software testing. And then we go to history base itself for test case prioritization. Since that we have in test case prioritization, we have different approach that I have mentioned before. So one of it is history based. Okay, this is a few paper that have been collected recently. From the first one is Marichan and for the Marijan, it's utilize the use of false status time execution for testing to prioritize the test cases for their in terms of software testing. And then for the second paper, it tried to adapt the Marijan paper itself, but they utilize they tried to use the statistical data analysis to determine the weightage assigned. For example, because for Marijan itself, they try to use the domain specific heuristic for the weightage assigned. And then for the partition itself, unlike partition, they try to come up with different factor, which is focusing on the code change itself, and which utilize three few factor, which is revision, fix, and alter. And for the revision, it's how frequent the class code change, which mean that if the code frequently change, it could possibility has a high priority compared to the test cases that has a lowest. And then in terms of the fix, means that how frequent the class could be fixed. It means that how many times that if it's fault and then the test cases itself have been fixed. And then lastly is the author. It's focusing on how frequent the author modified the code itself. And for the petition itself, it's utilize the use of defect score to calculate all the priority values. Okay, from here we can see that both of these paper utilize the use of fault base, and only one paper utilize the use of code change for the proposed method. And then only Peterson utilize the use of tools for bug prediction, and for the optimization they try to use the greedy and additional greedy algorithm instead of both paper neglecting this factor. Okay, the summary, each paper proposes different type of factor with their sign for the respective test case priority score. As we can see here, there are this one is more heuristic, statistical analysis, and this one is focused on defect score. And then two paper utilize the fault status information, while the one paper utilize the code change information, as I've mentioned before. Different weightage assigned for each research paper. Only one research paper has secondary objective to optimize the proposed technique, which is the Peterson one. And then we go to the use of community testing in test case prioritization. Okay, so this is a few paper that have been review. Okay, from here we can see that most of the paper try to use iteration parameter value, iteration coverage, and coverage, and most of them are utilize the coverage based and iteration coverage based approach in terms of TCP. And in terms of weightage assigned, we can see here only most of them are individually utilize each of proposed weightage assigned based on the theoretical implementation of the approach. For example, like interaction coverage, they utilize they were based on the CTC and UTC, which is for interaction parameter value assigned. They want to see how many interaction parameter that will cause the in terms of the theoretical evaluation, and then the user assign for UTC. For the UTC factor, they try to assign the use of user user assigned weightage, which is really depend on what the user assign. And then for generating the test cases, they use the tools for Act tool. And then, for example, like the first paper, they utilize the use of BDIF algorithm into consideration, and in terms of evaluation itself, they use fault-based metric and coverage-based metric. And from the second paper, this one is more focused on interaction coverage instead of interaction parameter value and user assign, which is quite slightly different. However, it's not specified what is the weightage assigned and tools to generate the test cases. And this utilize their own proposed repeat small strand value of tests between in the range of 1 and 2 and 1 to the algorithm. And the evaluation metric that they utilize is FPFD, average percentage for detection, and FPCC. And then for the third one, it's focusing on the coverage, which might slightly same for the interaction coverage itself actually. But in this paper, it's more focused on the use of the strength of from 2 until 6, where they want to find the optimal strength for the test case generation in prioritizing it. And then in terms of and then for this paper, it tried to use a weight coverage and KL divergence, which they come up with the parameter value assigned, and it's also and then in terms of the test case generation, they use a Precode, that is an open source program that has been available, and integrate it, and then it try to integrate it, focus on prioritizing and frequency focused prioritization. And then it's for the in terms of evaluation, they use the normalized FPFD. And then lastly, this paper is want to use they use the parameter value, most likely the same for this one, parameter value assigned. And they also try to they use the tools that are available open source to generate the test cases, and they use the normalized FPFD value. From this literature review, the factor for weighted assigned operativity are different for each research paper, and most paper coverage based and interaction coverage based. And some paper utilize the use of available tool to generate the test cases. And most common evaluator metric is NFPFD and FPCC, and the common one is a project, since it's available online and easy to be accessed. So this is the research conceptual framework, which from here we from the literature review itself. So we collect the information, find a gap, and implement implication, and then we try to come up with the proposed solution. Here we want to enhance the history base by utilizing the fault count of fault status. Actually, frequency could change into consideration, since that most of history base focusing on single factor into consideration. So in here we want to consider group of factor. And from here, we propose a solution where we integrate the use of Siti and test case prioritization. And for the testing part, we utilize the use of EMA dataset, which is SER dataset itself, and a case study from PNP, Patient Navigation System. And for the evaluation metric, we use the NFPF. So this is a operation framework which start most likely, like I have mentioned before. First is focusing on the research gap, and then this one is for designing the framework, research framework, and then the third one is more focus. Okay, for the third one is focusing the experiment itself, where we try to know what is does the history based. For example, like here we focus on history based and compare to non-history based. Does history based itself influence the effectiveness of the testing in Siti? Then we go to the fourth experimental, which after we do some experiment on this here, we enhance our history base, and then we try again with the Siti itself, and then we measure the effectiveness of our proposed method. And lastly, we go to the experiment for the case study, which is the patient navigation itself, and lastly the documentation. Okay, so in here we have three different setup of experiment. First one is we want to study the use of Siti in history base, and second one is study of enhanced history based TCP, and lastly we want to study the proposed approach compared to existing approach. Okay, for the first experiment, we want to see the use of Siti in history, where okay, for this one, we try to, first step is we generate the test cases, and then we go to the prioritization part, where the test, after the test is generated, we prioritize it according to, this one is focusing on history based, and this one is non-history based. And then, okay, this is the data set used, and lastly, we evaluate the proposed method, the study using the MPFD. This is the evaluation metric that have been used, MPFD, compared to this is the subset of the part of actually is original from the MPFD metric, but we try to normalize it since that sometimes for test case generation, the test case itself could be reduced, and sometimes the fault itself could not be found. So instead of using MPFD, we use the MPFD into consideration. And then, okay, this is example of data that have been executed during for this experiment. We try to use at least two versions, since that we focusing on history, for sure we can't only consider only one version. So here we utilize the use of two version, and then we start from here. It shows that it's slightly improved for history based compared to non-history based in terms of effectiveness of value of FPFD value. Okay, then we go to this one is focusing on the use of Siti in history base. So we want to study either the history base itself influence the effectiveness of the Siti in terms of effectiveness of test case execution. Then we go to the enhanced history base itself, where we go from this is the process itself. Start from the data set, we gather the test cases, and then we try to collect the fault status and frequency change from respective test cases, and do the algorithm and start to prioritize the test cases. And then for the evaluation, we go to the fault metric and using the FPFD value to prioritize this, to know the result of this experiment, either it improve the effectiveness of our enhanced purpose solution. And then we go to the third experiment. Actually, both experiments are still in progress, so I just show the process. Okay, for the third experiment, this is the purpose experiment, where we from the data set itself, we generate the test cases first using the combined testing technique, and then we utilize it. From there, we cut the test cases. From there, we recruit the fault status and frequency change from the previous version of test cases, and then we go to then we prioritize it utilizing this factor. And a same goes to evaluation, where we go back to the fault matrix itself to calculate the MPFD value for this respective technique. Okay, then we go to discussion itself. History-based algorithm that use enhancement only dependent on fault status. Okay, status of the test execution of previous test cases to other test cases. From this experiment, actually, the first experiment here, we just only focus on the use of fault status instead of frequency change. So later on in the enhancement, we try to embed both of these. So in this discussion, I want to highlight that part actually. And then the result of NPF, history-based approach adapting in Marijan give a better result in terms of effectiveness in detecting fault compared to Sati that I have compared before. Here actually slightly improved from version 1 from version 2. And then for the missing fault found during the test execution become problem when generating the test cases into a small number of combination different parameter value. For this missing fault found means that sometimes when we generated the test cases using combination testing, the fault could be found compared to if we execute the entire test cases. Some test cases. Okay, then we go to for one, we want to highlight the flexi program and only consists of many single value, since that we are utilizing the use of combined testing where we want to combine different parameter value, and it consists only fault status information, which from my experiment is quite become the limitation for my next proposed method. Then for the improvement for the future work for my experiment, we will conduct expand using other different factor, which is I highlighted before, which is the use of code change into consideration instead of only focus on fault status. And then for the second part is we try to use a different strength value of the way for the test case session, while the test to study either missing fault detection problem can be solved and what is the optimal strength should be used. Then lastly, we will use different data set, since that the flexi program only consists of fault status information instead of the code change information. So for that, I use an open source data, which is the defect4j dataset. And this is the current status of my study, which I focus for now. I have done a few experiments on the study of Siti in history-based. And then for next one is focusing to enhance the history-based itself. And then lastly, we try to embed in Siti and compare it with the existing approach. I think that's all for me. Thank you.
Okay, so there's one question from me. Can we see? Can I see the scope again? Okay, so are you focusing on general test case prioritization or regression testing?
For my experiment, actually, I will focus on general. Actually, since that I try to embed it in commit. So I actually, for my test case presentation here, I will use into a regression where we try to regression. We try to use regression, since that it will utilize the use of the change itself in the, for example, like for the functionality change, the code change itself, either it influence the effectiveness of the proposed solution.
Okay, so normally when you use history-based, it's for regression testing, right? Because need the historical
yes,
execution.
it should have multiple version of execution of program itself.
So I think maybe you can include in scope focus on regression testing.
Assalamualaikum, Syafiq. I suggest very simple comment lah from me. For example, the slide, provide the slide number lah. So so easy for the audience, for the examiners to highlight which slide number to refer to. Can you go to conceptual framework slide? That's why I cannot say the slide number now. Okay, like this. Okay, just want to correct in terms of the terminology and what I believe this will be in your thesis later on lah. Okay, so here you have your literature review. At the same time, you have your next slide. You go to operational framework, you call it, right? This is why Zulaikha said just now, research framework, but I said research procedure. Okay, Zulaikha, if you want to see operational framework, I think that's correct lah. You say the framework, that means the steps taken in your research, or most of the time you also call it research procedure. Okay, reverse, go to previous slide again. So here you have literature review. You can see like you have conceptual framework with the literature review that also actually stated in your operational framework, right? Or research procedure. So here actually what do you understand about conceptual framework? Is it a conceptual framework, or actually can I say that actually you try to come up with theoretical framework and to say that, oh, I have the proposed technique here. In theory, I did share this lah in one of the under PTSS. In theory, your work is actually located or positioned in which part. So I see that, okay, you have good diagram here to position your work. But the naming, when you say conceptual framework, I must say conceptual maybe your proposed framework, your work. But otherwise, I suggest you use theoretical framework. There are arguments also in these terminologies lah, in terms of theoretical framework versus conceptual framework. But I would say the conceptual framework is more on those working on the model and framework level, then they have their conceptual framework also. So in this case, I believe it's theoretical framework where you want to position your work. You agree or not, Syafiq, actually? In theory, you want to highlight why do you say conceptual framework? You don't propose a framework, isn't it? You propose the prioritization, the strategy, or the technique, isn't it? That's my terminology elaboration lah. You can have
So usually we call it
theoretical framework in my opinion lah. Because now your literature review shouldn't be there. I don't think you should. In theory, theoretical framework will be to highlight in my problem domain, test case generation, prioritization. Okay, I think, but the literature review should not be there. That one is more of your operational framework or your research procedure, Syafiq. That's my opinion lah. When I see this diagram, it's like a mix of what you want to do in your research. You have literature review. At the same time, you call this conceptual framework, which I see is like theoretical framework. I just share my opinion lah, so that maybe when you write, you improve, then your TC will be better with all these good diagrams. Okay, Syafiq, that's all. All the best, Syafiq.
Okay, thank you again, Dr. Shaida, for the comment. So I think that is all for this session. And thank you, Mr. Syafiq, for the presentation. Okay, so yes, I think that is all for this session. So thank you again, everyone, for your participation today. We will see you again in the next curriculum. Stay safe. Assalamualaikum, and you may leave the meeting now. Thank you.
Waalaikumsalam. Thank you.